Okay, today we are going to learn about basic concepts regarding projection of straight lines. Okay, in this first we are going to see the case 1. Okay, so with respect to these cases we are going to learn the basic things about the projection of lines. Okay, so first case 1, it is a line parallel to HP and VP. So in this the line will be parallel to both HP plane and VP plane. Say if I am considering, so this is your vertical plane and horizontal plane. Here our line will be parallel to both HP and parallel to both VP. So this is what the condition. Okay, case 1, it is parallel to HP and parallel to VP. This is vertical plane and this is HP plane. It is parallel to HP and it is parallel to VP. So this is what our condition. So in this so we will deal with the problem. Draw two views of a straight line 60 mm long which is parallel to both HP and VP. Okay, so here you can see that the line, it is parallel to both HP plane and VP plane. Okay, and then they have given the line is so the length of line we got to know, it is 60 mm. Okay, so the length of line we have to draw, that is 60, and so it is parallel to both HP and VP plane. Okay, and here we have, so you can see that two views you have to draw, front and top view. Straight line 60 mm which is parallel to both HP and VP. The line is 20 mm above HP and 25 mm in front of VP. So here we are going to use only the first quadrant. So first I am going to draw an XY line here. Okay, so XY, VP, HP, first quadrant. Okay, so the line is 20 mm above HP. So above HP means it is our front view. So here vertically, so here I am marking 20. So this is 20 and 25 mm in front of VP. So in front of VP means it is our top view. So it is 25. So here we have to draw a line of length 60. Okay, so it is parallel means we have to draw a straight line. So from this end 6 boxes we can take, so 6 boxes here, and here also to draw for 6 boxes. Okay, so this is our line and we can show the dimensions. So this is our top view which is also 60 mm. Okay, so this is our front view. You can name it as B dash, B dash, and this is AB. So this is AB line of length parallel to both vertical plane and HP plane. Okay, we see second case in projection of lines. So the second condition is the line is parallel to VP and perpendicular to VP. So we have to make it parallel to HP and perpendicular to VP. So how to do that? Parallel to VP means here you can see this is our vertical plane, this is horizontal plane. In this condition we have to make it parallel. So you can see here this is parallel to HP. So this pen, it is parallel to HP and it is perpendicular to VP. So perpendicular means you will get a dot here. Okay, you will get a dot on the vertical plane and there is a straight line in the HP plane. So this is what parallel to HP and perpendicular to VP. So like this we have to do. So first we are going to draw an XY line. Okay, XY, VP, HP, first quadrant we are using. Okay, so here the end of the line, so line it is you see it here, line AB long parallel to HP we have to make and perpendicular to VP. The line is 20 mm from HP and 30 mm from VP. So 20 mm from HP means it is 20 mm from HP. So 20 mm above HP means it is in the front view. So here, so above HP means here, and 30 mm means here downward. Okay, here you can show the dimensions. this is 30 and this is 20. So here from this end we have to draw an parallel line. Okay, see this line 60, these 6 boxes. So it is A, B, line of length 60, and here we'll put a dot, that is A dash and B dash. Okay, so this point it is perpendicular and this is parallel. Okay, so this completes the second case. Okay, we see a third case. So third case is line parallel to VP and perpendicular to HP. So how to do this condition? We see it here. So this is our vertical plane and this is horizontal plane. So in this condition here, the line it is parallel to VP, straight line, we get it in VP plane, and perpendicular to HP means we get a dot in the HP plane. This is what the condition, parallel to the VP and perpendicular to HP. So like this we have to do. Okay, line of length we have to draw a 50 mm. So here it is parallel to VP and perpendicular to HP. One end of the line it is 20 mm above HP and 20 mm in front of VP. So first we are going to draw an XY line here. VP, HP and Y. So here both the ends of lines are at a distance of 20. So 20. So we can show the dimensions on one side. Okay, from this end, so here we have to consider 6 boxes. This is A dash, B dash, and we can show the dimension here on one side. Okay, 60. And here we are going to put a dot. This is AB. Okay, so it is perpendicular to HP and parallel to VP. So this condition also so done. The fourth case, that is line inclined to VP and parallel to HP. Okay, so parallel to HP. So how it is here, you can see this is our VP plane, this is HP plane. So here you can see this is parallel to HP and parallel to VP. So here you can see that this is inclination, we are giving inclination. So whatever the inclinations here, so we will be giving like this. So it is what the inclination to VP. So this inclination to VP, so whatever we give, say this is what the inclination to VP and it is parallel to HP. Okay, so like this we have to do it. So here first I am going to draw an XY line. So VP, HP and Y. So 30 mm above HP and 20 mm. So here we can show the dimensions. Okay, so here it is. So this is 20 and this is 30. So whatever the inclinations we have given inclination to VP, that is we can show it in the VP plane. So sorry, in the HP plane. Inclination to VP, so we have to show it in the HP plane. So inclination to HP, let's say some 45 degree, we will give the angle 45 degree. Okay, here. So here I will take an angle of 45 degree and line of length. So line of length we have to take, that is 50 mm. And here the angle we can 45 degree. Okay, this is A, this is B. Now projecting upward, here we get the front view. So this is B dash, B dash. Okay, so this completes the problem. You can see, so this is true length of line. So it is 50. It's 50, right? So if the length of line, if this remains in after projection, say we calling that is true length of line. Okay, true length of line. If the length of line, if it is reduced, okay, after projection, we calling that as an apparent length of line. Okay, apparent length of line. Okay, so true length of line means the length of line will be remain same after projection. So that is true length of line. If the length of line it is get reduced after projection, we calling that as apparent length of line. Okay, so this completes the problem. See a fourth case in projection of line. So line is inclined to HP and parallel to VP. So here we have to give inclination to HP and make sure that line parallel to the VP. So how it is done? So you see it here. So this is vertical plane, this is horizontal plane. Say in this condition it is both parallel to HP and parallel to VP. So now what I'm going to give inclination like this. You can see here. So this is what the parallel to the VP, but here it is nothing but the inclination from the HP plane. Okay, it is inclined to the HP and parallel to the VP. Parallel to the VP means we get a straight line. So inclination to HP means either it is 30 degree, 45 degree, 90 degree. Okay, so this is what the inclination to HP and parallel to VP. So this is how we have to do. So for that, first I am going to draw XY line and first quadrant. VP, HP, Y. So you can see here the end of the line is 20 mm in front of VP, 30 mm above HP. So 30 mm above HP means here this is 30 and this is 20. So here the end of the line here you have to give the angle here first. It is inclined to HP. So whatever the inclination to HP it is there, it is seen in the front view. Okay, so it is seen in the front view. So here I am going to mark angle 60 degree. Okay, so here I am going to draw a line of length 60. line we have to draw. So 1, 2, 3, 4, 5, 6. Okay, 6. So it is having angle of 60 degree, and this is A dash, B dash, and this is the length of 60. So now projecting downward, so we get the length of the line here. So this is our top view, A, B. Okay, so here this is what inclined to the HP, the inclinations to the HP, it is shown in the front view, that is in the vertical plane. Okay, so it is inclined to HP and parallel to VP. So this condition also done. Okay, we see some basic concepts in projection of lines. So as we are solving the problem, we should make sure. So we know that we have true length of line. We know that true length of line in top view, it is exactly equal to the true length of line in front view. Okay, so that is the first concept. And second concept is the true length is always greater than the apparent length. Okay, so be remember it. True lengths are always greater than the apparent length. And then apparent angles are always, which we find out, apparent angles are always greater than the true angles. Okay, this is the one of the difference. So when we are solving the problem, we should make sure the true lengths are always greater than the apparent lengths and apparent angles are always greater than the true angles. In the true lengths in top view and true lengths in front view, it is always the same. Say true length is given if it is 80 mm in front view, and in the top view also true length is exactly 80 mm. Okay, so that's what. So the basic concepts in projection of lines. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first the end of the line, it is inclined end A, it is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP, so this is 20 and 30 means here. Okay, so you can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. You have to find out the apparent length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first you are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree to VP. And here line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the apparent lengths. Okay, so how to find out the apparent lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of A, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length, we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cutted, we have to join from here to here. So this is AB. This is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is P2 dash. So by measuring from compass, from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut it. This is A dash, B dash. Okay, so this is nothing but the apparent length. So this A dash, B dash. Okay, apparent length we are going to measure how much it is. Apparent length, it is measuring 57 mm. Okay, so okay, 57 mm apparent length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And apparent angles, inclinations also we have to find out. So how much we are getting. So apparent length, inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we're getting apparent lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A, 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem, we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first, the end of the line, it is inclined end A. It is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP. So this is 20 and 30. 30 means here. Okay, so you can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. You have to find out the apparent length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first you are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree to VP. Okay, line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. Okay. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of A, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length we have to cut the arc. Okay, so this point I'm going to give this one as B1. Okay, so where the arc has been cut, we have to join from here to here. So this is AB, this is AB. The same way from B2 vertically upward till locus of A dash. So I will draw a straight line. So this is B2 dash. So by measuring from compass, from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut. This is A dash, B dash. Okay, so this is nothing but the upper end length. So this A dash, B dash. Okay, upper end length we are going to measure how much it is. Upper end length it is measuring 57 mm. Okay, so okay, 57 mm upper end length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And upper end angles, inclinations also we have to find out. So how much we are getting. So apparent length inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we're getting apparent lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. Okay, so we are going to solve second problem from the CAD solution book. Okay, in the projection of lines. Okay, in this problem, line AB 80 mm long is inclined at 30 degree to HP and inclined to VP at 45 degree. So draw the front and top views of the line and determine their length. So in this problem they have mentioned true length and the angle of inclination to HP and an angle of inclination to VP they have given. Now we have to find out the apparent lengths and apparent inclinations. Okay, so proceed with the problem. So first I am going to draw an XY line here. Okay, so any one of the reference point I will take here. This is A dash and A. Okay, here, so they have not given any end of the line distance, so no need to draw the locus. The locus line, it is there on the XY line. So first inclination, it is inclination to HP at 30 degree, and here we have to draw a line of length AD passing through this point. So this is 30 degree, this is B1 dash. Similarly, we have to mark another angle at 45 degree, and this also having a length of 80. So this is B2. Now we are going to draw a locus line here. This is locus of B2 and this is locus of B1 dash. Okay, so now the procedure here it is, we have to project it downward till here. Okay. Now we have to take the compass. Measuring from here, so we have to cut the arc. This then we have to join. Okay, so I'm going to dark this length, and this is our apparent length KB. Now I have to project it upward. So arrow mark I'm writing here. So we have to join here. So this is A dash, B dash. Okay, there are two apparent lengths we got. Now we have to measure the angle. Okay, apparent length angles. So here we have, so this is around 45 degree. This is alpha 45 degree. And this is beta. This is Q. So this is we are getting beta 55 degree, and this is 45. So we need to measure these lengths. is around 57 mm. So we will write here A dash, B dash 57 mm, and AB. So alpha we are getting 45 degree. So beta we are getting 55 degrees. AB length we have to measure. AB I am getting around 68 mm. So these are the things we have been find out. Okay, in projection of line. You can like the video, subscribe and share, and hit on the bell icon. Okay, we see another problem, that is problem number 3 from CAD solution book. Okay, so in this problem they have given line AB has its end A 20 mm above HP and 30 mm in front of AP, and the other end 60 mm above HP and 45 in front of AP. Okay, and the distance between the projectors, end projectors given 70. So in this problem they have not mentioned either true lengths or any kind of inclinations. Okay, we have to use these end line distances so to do the problem. Okay, so now we are going to proceed with the problem here. First I am going to draw an XY line. Okay. So XY AP HP. So one end of the line is 20 mm above HP and 30 mm in front of AP. So 20 here and 30 here. Okay. So here we are going to show the dimension. So this is 20, this is 30. This is A dash and this is A. And then other end is 60 mm above HP. Okay, 60 mm above HP. So that is 6 boxes. Consider 60 here, 60. So what I will do 60 it is, and here it is 45. Okay. So this is 45. Now I am going to draw the locus lines here. Okay. Okay, this is locus of B1 dash, this is locus of B2, and this is locus of G, and this is locus of A dash. Okay, now another thing what they have given in this question is distance between projectors. So distance between end projector is 70 mm. So I am going to draw that. So here distance between end projector is 70. So here I am going to draw on vertical line. Joining it. So here I am going to mention this is B dash and this is B. We know that as the apparent lines were drawn, so the end points, if you draw a straight line, so it will be falling in a straight line. Okay, so that's why we are getting this B dash and B on a same line. So I'm going to join this. So this is apparent length 1 and this is apparent length AP. Okay, so these 2 points we are getting it. So now using these 2 points we are going to draw, we are going to find out the, okay, so reverse here. So in this problem we have to do the reverse process to get the 2 lengths. Okay, so now we join from here. So this is B2. Okay, that is 1 2 length. Now again from this end so I can show the arrow mark direction in which these things are going. So now we will join this. Okay, so we'll find out the distances here. So true length we are getting around AP2 and A dash P1 dash, it is AP2 mm, and AB we are getting around 72 mm, and this is B1 dash 81. So AB1 dash is 81 mm. So we have to find out the angle of inclination for the two ends, or upper end lens. So here we are getting around 30 degree alpha. So alpha here we are getting it is 30 degree, and beta we have to find out. So beta we are getting around 20 degree. Okay, so this problem it is done. Okay, we solve another problem from CAD solution book, that is problem number 5. Okay, so what is given in the question? The top of weave PQ of a straight line, the top weave PQ of a straight line is 70 mm. So they have given the top weave of 70 here and makes an angle of 60 degree with XY. The end Q is 10 mm in 10 end Q is 10 in front of VP and 30 mm above HP. The difference between the distance of P and Q above the HP is 45. So draw the projections and determine its true length and true inclinations with HP. First we are going to draw the end points. So for that first I am drawing an XY line here. Okay. So VP, HP, Y. So end Q distance given. So end Q is 10 mm in front of VP. So from here it is Q and 30 mm above HP. So here it is Q dash. So we will show the dimensions. This is 30 and this is 10. And here another thing, the difference between the distance of P and Q above the HP is 45. So the distance between this P and Q, we have to consider the distance of 45 here. From this here I am going to consider 45 here. Okay, sorry, till here it is 10, 20, 30, so 45. Okay, so here I am going to draw on locus. And here also I am going to construct a locus line here. Okay, and here also the locus line. Okay, now so with the question they have mentioned, so the top weave PQ of a straight line 70 mm. So 70 mm, so with the angle of 60. So here, keeping at this point, so marking at 60 degree, I'm going to draw 60 mm line here. So this is having inclination 60 degree and this is P. So here I am going to draw a locus line, another locus line here. Okay, so now to find out the true length, this is one of the upper end length, right? So upper end length will always be rotated, you remember it. So So apparent length, it is going to rotate it like this, and then project it upward, so to get the true length here. This is true length. So this is, so you can say P1 dash, P1 dash. Now, so we are getting one apparent length and one true length. Okay. So now we have to get another apparent length. How to do? We know that apparent lengths, when they have been projected, so they are falling in a straight line. So I'm just drawing a straight line here. So this point we having, this is P dash. So now we are getting another apparent length in front view. Okay. Apparent length in front view. Now we are going to rotate this apparent length so in this direction, and projecting downward. So this is, we have another true length. So we are going to measure the true length. So true length, we are getting around 76 here. Okay. So you can write here, so you can write it Q dash P1 dash is equal to Q P2. You can measure here. It is around 75 mm we are getting. Okay. And true angle of inclinations we have to find out. So the first angle we are getting, it is around 37 degree I'm getting. This is side 37 degree. Okay. Second angle I am getting around, so this is theta and this is psi. So psi I am getting around 45. So this completes the problem. So remember it. So always apparent lengths are going to be rotated. Okay. So I'm going to make this apparent length darks. Okay. So apparent lengths are always rotated. So true lengths are never be rotated. Okay. So remember it. This is one of the important point. So apparent lengths are rotated using compass. Okay. So we never rotate true lengths. So this is one of the important note, you can say that. Okay, apparent lengths are always rotated when we are doing the problem. True lengths were never rotated using compass. Okay, so that is important thing. Another problem from CAD solution book. It is problem number 6. Okay, so in this they have given line PQ, true length 85 mm long, as a end at P 10 mm above HP and 15 mm in front of VP. In the top weave and front weave of line PQ are 75 and 85. So these are the apparent lengths they have given. So this is true length 85. These are apparent lengths. So using these things we have to solve the problem. So we have to find out the true and apparent inclinations in this. Okay. So first I'm going to draw an XY line here. So XY, VP, HP and Y. So the end points first time write 10 mm above HP. So 10 mm above HP and 15 mm in front of VP. So here I'm going to draw a locus line. So wherever the end points were there, we have to draw an locus lines. Okay. So this point is P dash and this is P, and it is having a dimension of 15 and this is 10. Okay, in the top view and front view of line are 75 and 80. So the top view here, so this here on the HP plane we get in top view, so it is of 75. I'm going to measure 75 from the scale. Okay, 75 from the scale I'm going to measure, and here I'm going to cut the arc. Okay, and then I'm going to extend this, okay, extend it with the straight line. Now I'm going to measure 85 from the compass and using scale. I can measure and I can cut the arc. Okay, so then join. So this is having 85 mm and true length it is 85, and this is Q1 dash. So here on locus line here. Okay, so now we are getting the two lines, 85 here and the locus line. So next thing we have to do is again we have to consider this. The front view we have 80. Take here from the scale 80. So from this end I'm going to draw an vertical line here downward. Then again I'm going to measure 85 from the scale using compass. Okay, so now I'm going to cut the arc here. So here is another true length. Okay, this PQ2 is also 5 mm. Okay, so if here we get another locus line. Okay, so now using this 75 mm here, we're going to cut the arc. So exactly here, this here we're getting the upper end length PQ, and here upper end length PQ dash. Okay, now we have to find out the angles. Okay, find out the angles. So first I'm going to find out the theta. So theta I'm getting around, so how much theta, it is around 28 degree. Okay, psi we have to find out. Alpha also, alpha is going to find out. So alpha I'm getting around so alpha I'm getting around 28. Alpha I'm getting around 28 degree here. Now psi we have to find out. Psi we have psi have 20 degree, and beta I'm getting around 23 degree. Okay, so this completes the problem. We do another problem from CAD solution book. It is problem number 7. Okay, so what is given? A line has its end 10 mm over HP, 15 mm in front of VP, and end B is 15 mm above HP. And the line is inclined at 30 degree to HP and 35 degree to VP. And the distance between the end projectors given is 50 mm. So now we have to use, we have to go step by step here. So first I'm going to draw an XY line here. Okay, XY VP HP. Same points, 10 mm above HP means this, and 15 mm front of VP. And here we have locus line, and here also we have locus line. Okay, so this is A dash and this is A, and it is having a dimension of, so this is 10 and this is 15. Okay, now another end we have, that is 55 mm from here, that is, so 55 is still here. Here another locus. Now, so we have to use inclination. The line is inclined at 30 degrees. So this is nothing but inclination to the true length. Okay, so from here we are going to mark for 30 degree. Then we are going to draw a straight line passing through a point. Okay, so this is 30 degree and this is B1 dash true length. Okay, and another one is 35 degree to VP. I'm marking at 35 degree and draw a line. We have to find out how much length. So because we know that true lengths are same in both top view and front view, so we have to use this. So here we have true length, I'm getting around 88 mm. So this is the true length. So here also we have to draw another this is 35 degree. Okay,
ಅವರು ಅಲ್ಲಿ 45 ಮಾಡಿಬಿಟ್ಟು 2 ಸೆಕ್ಷನ್ ಮಾಡಿ ಸಿವಿಲ್ ಸೆಪರೇಟ್ ಮಾಡೋದಂತೆ ನೀವು ಬರ್ಬೋದು ಕರೆಕ್ಟಾಗಿ ಇಲ್ಲ ನೀವು ಬರ್ಬೋದು ಇವ್ರು ಹೋಗಲ್ಲ 2 ಸೆಕ್ಷನ್ ಮಾಡಬೇಕು ಗೋವಿಂದ.
So now we have to find out the angle here. So upper end angles we have to find out. Alpha, I'm getting around alpha 32 degree, and here beta I'm getting around 44 degree. Okay, and true length we have A dash B1 dash and A B2, it is around 88 mm. So that completes the problem. Okay, we solved the problem number 9 from CAD solution book. So it is, you can see in this problem they have given line of AB 60 mm as one of its extremities. Extremities means end point. Okay, so 20 mm in front of VP, 15 mm above HP. The line is inclined at 25 degree to HP and 40 degree to VP. So now we'll proceed with our solution here. So first I'm going to draw an XY line here. Okay, X, VP, HP and Y. So end point here 15 mm above HP, 15 mm, and it is, and 20 mm in front of VP, 20 mm in front of VP here. So here we are going to draw an locus line. This is 15 and this is 20. Okay, 15 and 20, and this is A dash and this is A, and we have angle of inclination here. So 25 degree to 25 degree to HP, okay, and 40 degree to VP. So 40 degree to VP. Here the length of line we have to draw, that is 60. Okay. Here to these extremities again another locus line. So this is the AB2, another length of line 60 we have to draw this end. Okay, here another locus line. Okay, so this is B1 dash, and show the dimension here 60. We can show the dimension. So this angle it is 25 degree, this angle it is 40 degree. Okay, so now this is true length. Now we have to find out the apparent length. So apparent length, it is going vertically downward till the locus of A. Now we have to take the compass and we have to rotate it till here. Okay. So here at this point we are getting apparent length AB. So we have to dark this apparent length. Okay. Now from this end this is A dash, B dash. So this is what I want to tell. So if you just draw a straight line connecting the apparent length top face and the bottom face, okay, so this front view and top view, it is drawn, you'll get the straight line. Okay, that is what. So you can see A dash and A dash, A it is in the collinear line, and B dash and B in the collinear line. Okay, so this completes the problem. Okay, now we can find out the apparent length angle inclinations here. So apparent angle we have, so first angle we have here is around alpha is 34 degree, and this we have, it is around beta. So beta angle we are getting around 40-60. Okay, and then apparent length we have to find out. Apparent length, this is AB we have 55 mm, and B dash we have 46 mm. Dash B dash 46 mm. Okay. So this completes the problem. You solve problem number 10 from CAD solution book. So in this line AB measuring 70 mm has its end 15 mm in front of VP, 20 mm above HP, and the other end B is 60 mm in front of VP and 50 mm above HP. So first I'm going to draw an XY line. VP, HP and Y. So 20 mm above HP means here 20 and 15 mm means here. So here we are going to draw an locus line. above HP. It's 50 and 60 mm in front of VP. So here also we can draw an locus line. So this point it is A dash and this is A. So we have a line of 70 mm. So we have to measure 70 mm from 70 mm 7 cm from the scale. Okay. So and we have to cut the arcs from this end to here, first arc, and the second arc from this here to here. Okay. So now we have to join. So these are nothing but two lengths. Okay. A, B, 2, and here from this end to here, this is B1 dash. This is having exactly 70 mm. And this also 70. Okay, now so projecting upward this line here, and from here we have to rotate this upper end length till here. Okay. This is B dash. Similarly, so we can project it downward till here, and showing from here we can cut the arc and can join this. This is AB. So now we can measure the length here. So A dash and B dash, it is around 55. So sorry, not 55, it is around A dash, B dash. So we have to find out here inclinations. Okay, not the length here. You can see here, find the inclinations. We have to find out the inclinations here. So inclinations, what we are getting, both the inclinations we are getting. First angle we are getting around, it is theta in 25 degree here. This is 25, it is theta, and alpha we are getting, this is 34. Now here psi we have to find out. Psi we are getting around 45 degree. This is psi. Okay. This angle getting around, it is beta we are getting 55 degree. So sorry, psi we are having 40 degree. And this beta we are having, it is 35. So you can mention the angle here: theta 25, alpha 34, psi 40 degree, and beta 45. Okay, so this completes the problem. Okay, so when you are doing it, so always make sure you have to dark this upper end length. Okay, you have to dark the upper end length. The upper end length has to be more thick compared to your true length. Okay. Today we are going to learn about midpoint problem in lines. So it is problem number 37 from CAD solution book. So you can see in this problem, draw the projections of a line AB 90 mm long. So here they have given true length of line, okay, and find its true and upper end inclinations. We have to find out, that is theta, psi, alpha, beta, everything. So with HP and VP, when end A is on HP and 20 mm in front of VP. So for the end A they have given the distances, and for the midpoint M, it is 20 mm above HP and 40 mm in front of VP. So now first we are going to draw XY line, then for the end points we are going to draw. Okay. So X, VP, HP. So end A here, you can see that end A is on HP and 20 mm in front of VP. So 20 mm in front of VP. So here we are going to draw an locus line. So this distance it is 20. Okay, for the midpoint we have 20 mm above HP, 20 mm above HP here, and 40 mm in front of VP. Okay, 40. So here also we are going to draw an locus line. Okay, so I'm going to mark a middle point here. This is M dash, and here we have M. Okay, so middle point it is drawn. So now we have true length of line, it is 90. So half means it is 45. So we have to consider. So 45 length I have considered. Here from this point on the XY I'm cutting first arc. Okay, so now we have to join. Just so it's beautiful. So we can extend it. Another 45 length. So extend it. So this is A dash and this is P1 dash. Now here we are going to draw another locus line. Okay. And this is having the length of 90. So it is having a length of 90 mm. Now same way, so we already measured 45. So from this end here we are cutting the arc. So this is E. So we are going to extend this till here. So this is D2. Okay. So another locus line is drawn, and this is having the length of 90. Okay. So now we have to find out the upper length. So we have to project it from B1 dash till the middle point of M. So where the locus of L is there, till here we have to extend. So from this end to here, measuring this length, so we have to cut the arc. So now we can join it. So this is B. Okay. So we have to extend from here till the locus of M. Okay, so till the locus of M we have to extend. So measuring from this length to cut the arc. Can show the another direction here. So we are extending it. So this is A. Now in the same way, so we are going to extend from this A till the middle point of M here. Okay. Now measuring this length to here. So we have to cut the arc till the locus of E. So we have to join it here. Again from extending from this point to the locus of M. Okay, measuring this length, you have to cut the arc. So this is the direction in which it is cut. Now from here to here, we have to join. Okay. So this is V dash. Now we have to find out the angles. So you can see that we have to find out the angles here. So true length angle, that is theta, we are having 25 degree, and alpha we have around 29 degree. Same here. Psi we have 26 degree, and beta we have around 31 degree. Okay, so this completes the problem. So you can like the video, share it, and subscribe for the channel, and hit on the bell icon. It is one of the special type of problems in lines. It is problem number 39 from CAD solution book. So you can see in this problem there are two lines given, two lines AB and AC makes an angle of 120 degree between them in their front and top view. Okay, AB and AC, so that will be making an angle of 120 degree, and AB is parallel to both HP and VP. Okay, so we have to make AB, so both parallel to HP and VP. Determine the real angle between AB and AC. So how we do that? So first we have to draw an line here, XY line. So I will take here only. So XY line, XY, VP, HP. So first I will draw a line AB. So you can see that AB line parallel to both HP and PB. So I will take around 6 mm length line. So this is A dash, and this is B dash. Okay, the same manner here, parallel to it, because the AB line it is parallel. Here I am considering 60 mm. Okay, so this is B. So AB line, you can see that line AB, it is parallel to both HP and VP. It is parallel to both HP and VP. Now AB and AC makes an angle of 120 degree. So here I take marking at 120 degree here, and then marking it here also 120 degree. Okay, so we have been marked 120 degree. Now I'm going to join this line. Okay, so line of length will take around here will take around here 50. Okay, so 50 will take here this BC length. 50. Okay, so this is C dash, and here BC. So 50 will take, okay. So BC. So here we have angle 120, and this is also we have 120 degree. So this is done. Now, so we are going to join it from this end to here we have to join, and here also. So we have to join. Okay, here I will draw locus lines. Here also we have to draw the locus lines. Okay, here also we have to draw the locus lines. Okay, so now after this, what we have to do is, so we have to measure the length from here B to C, measuring this length. Okay, so we have to cut the arc. So this is, we have this C1, and now measure this length. So this length is C2. Now, so this is will give C2. Now projecting upward till here. Okay, so till here we have to project it. So now we are going to join this. So at this point we have C1 dash. Okay, and this point we have C2 dash. Now after this, what I have to do is, we have to measure the length from here to here. So I have to cut one arc, and after that measuring from here, so we have to cut this arc. So here, so this point we have, this is C2 dash. Okay, this point. So this point we have to join here. This point we have to join, and now from here to here I'll join. Okay, now this angle we have to find out. Okay, so this angle till here. So the real angle between the lines here we have. So we're getting here real angle. So real angle we are getting around, you can see here it is 112 degree. So 112 degree is the real angle. Today we are going to do midpoint problem in projection of line. Okay, so this is one of the important problem. Here in this problem, a straight line given AB measuring 80 mm long has the end A is in the HP and 25 mm in front of VP, and the midpoint M is 25 mm above HP and 40 mm in front of VP. So this is our problem. So first we are going to draw an XY line. Draw here. VP, HP and Y. So here in this the end A is in HP and 25 mm in front of VP. So 25 means here. So here I will draw a locus line. Okay, and one end it is in HP. So here we get. So now for the midpoint, so it is one end of the line is in 25 mm. So 25 it is done. Now here for the midpoint it is midpoint M 25 mm above HP. Okay, 25 mm above HP. It's 25, and this also. Here we draw an locus line here. Okay, locus line here will be drawn. Another is 40 mm. So this is 40. Okay. So here also we draw an locus line. Okay, so after this we know the straight line AB measuring 80 mm. So it is measuring 80 mm. So that means we have to take a compass and measure 40 here. So measure exactly 40 mm. Here from this end, any one end you can choose. Say I will choose this is our midpoint M. If I choose this is M. Okay. And here choose this is M dash. Okay, from this point, so we already measured 40 mm because it is 80. So I am taking half part, means it is 40. So we are taking 40 mm. Here I'm going to cut it. So after cutting the arc, I'm going to join it. So in a straight line, I'm going to extend this till 8. Okay, till 8 I have extended. So this point we have A dash, and this is B1 dash, and here also we get the locus line. Okay, same way here also we do. So already we have measured 40, so I'm going to cut the arc. Okay, here I'm going to join. Okay, I'm going to extend it. Here at this point we have to draw another locus line. So this point it is, so this point, sorry, so this point it is A, and this point is B2. Okay, this is A, this is A dash, and this is B1 dash. Okay, so it is done. So now you can see that this is our true length of line. Okay, so these are our true length of line measuring 80 mm. So now we have to find out the upper end length. Okay, so how to draw upper end length means here we have to project it downward till here. Okay, till the locus of M. So we have to project it downward by taking this length, okay, measuring this length here, measuring this length, we have to cut the arc. Okay. So till here. Okay. This is one point, this is B. Now in the same way, so we have to extend from this end till here, okay, till here. Now measuring from M to here. So I have to cut that. So this point it is B. So now we can join these two lines. So this we have the upper end length. Sorry, this is not B, this is A. So we have AB upper end length, we got it. In the same way, so we find out the upper end length. So we draw a straight line till the locus of M here, okay, till the locus of M. So from this point to here, measuring this length, we're cutting the arc. Join, and this is B dash. Again, extending from this end. Measuring this length from here to here. So I'm showing the direction of the arrow mark, in which direction we're taking it. Now we have to join so this is A dash, this is A dash, and this is B dash. So this completes the problem. You can see that we have to dark this upper end length. AB, and this is A dash, B dash. Okay, so this completes the problem. Problem number 25 from projection of line. So in this straight line PQ inclined at 40 degree to VP has PQ 60 mm and P dash Q dash 60 mm. So this is upper end length, and this also upper end length. So end P is both in HP and VP, and 40 mm from the right or the left profile plane. Okay, so draw the projection of straight line PQ, find the true length and true inclination with HP, draw the profile view of the straight line, and find the position of the end Q with HP. In this problem, we have to find out the side view also. Okay, side view. So first I'm going to draw a straight XY line here. AP, HP, and here. Right. Okay. So first, so we know the end point P is both in HP and VP. So that means it is P dash and it is P. And here P dash Q dash. 40 degree to VP has a PQ 60 mm. Okay. So PQ having 60 mm. So it is at 40 degree. So line of length we have to take here 60 means 6 mm. Okay, so PQ is 50 degree. So this is 60. So now so that is 40 degree to VP, that's why we have drawn a line here. Okay, so now so we know that we will drawing straight line here. You know that PQ it is 60 and P dash Q dash 50. So that means I will take, we know that upper end lens will be falling in a straight line. So now I am measuring 50 mm from scale. So measuring 50 from scale, I am cutting the arc here. This is P dash, Q dash, and here we have focus line. Okay, now I'm going to take this length and we are tilting now to find out the true length. Okay, so this Q2. So taking this length, so you can put this Q1 dash. You can rotate this also to get that. So it is done. This is 50. Now we find out now here. So from this end, so we'll be drawing a line of 40. You can see this here, 40 mm from the right of the left profile plane. So right of the left profile plane here, we're going to draw here another line for, so this is x1 and y1, and here and for the top view I'm going to draw 45 degree angle line. And here from this dash there is a line going in this direction. Parama direction. So this here we have Q double dash and this point we have P double dash, and this is our side view. Okay, our side view, and this is the dimension you have to measure. It is M, it is 22. Okay, so in this length also we have to measure. So this is having 38. So this area is here to 38. Okay, so now true length we are going to measure. True length of around 63. Full length in front view is equal to full length in top view, that is 63. Angles will be find out. Theta 20 degree, alpha 25 degree. In this side we have 38 degree. So beta 50 degree. Okay, so this is the length we have. Next we have M around 22, and we have 38. Okay, so this completes the problem.